So let me consider an example to show that whether the function is analytic. If it is analytic, we have to check its derivative. So I have an example: f of z is equals to z plus e to the power z. Okay, so then if it is analytic, so to check analyticity, what we are going to do, we have to satisfy CR equations. Okay, so if this function f of z satisfies CR equation, then we have to find dw over dz. So this is what we are going to find the derivative. So now here this f of z is nothing but w is equals to f of z is equals to, while we are discussing CR equations, we know that we have written this as a u plus iv, so which is nothing but here z plus e to the power z. Again this z is nothing but x plus iy. Okay, so I will write this as a x plus I y. Okay, plus e to the power x plus iy. Okay, so again this is equals to x plus iy. Okay, plus this e to the power x plus iy, I can write this as a raised to m plus n, which is nothing but a to the power m, a to the power n. Like this I can write e to the power x into e to the power iy. Again e to the power I theta, we know that we are going to write it as a cos theta plus I sin theta. Okay, so here if I simplify this, x plus iy plus e to the power x, again this e to the power iy, I can write it as a cos y plus I sin y. Okay, and now I'm going to separate real part with real part and imaginary part with imaginary part. So this is real part. Okay, so x plus e to the power x cos y, let me consider this as a real part, plus from this I'll take I common, and from this I'll take I common. So what remains here, I'm going to multiply this with this. So y plus e to the power x sin y. So this is the term we are going to write. This is nothing but u plus iy. Now real part, u is equals to what we have got, x plus e to the power x cos y. Okay, and v is equals to here what we have, y plus e to the power x sin y. This is what we are getting. Okay, so we have real part and we have a imaginary part. Then what we have to do, we have to find their derivatives. Okay, so now I have to differentiate this u, that is x plus e to the power x cos y, okay, with respect to x, that is ux I am going to get. So x differentiation is 1, plus since I am differentiating with respect to x, cos y will be treated as a constant, and e to the power x differentiation, e to the power x only, cos y I have to keep as it is. And the same term u I am going to differentiate partially with respect to y. Okay, so this way I am going to differentiate with respect to y. X is going to be 0, plus here cos y differentiation is minus sin y, e to the power x as it is, this is minus sin y. So I can write this as minus e to the power x sin y. So this is u subscript y, partially differentiation of u with respect to y. And similarly we have one more term, that is imaginary part, v. So v is equals to what we have, y plus e to the power x sin y. Now this v I am going to differentiate with respect to x partially. So this is going to be 0, plus e to the power x differentiation is e to the power x only, and sin y I have to keep as a constant because I am differentiating with respect to x. And then I am going to differentiate same v term with respect to what, y. Okay, so partially I am going to differentiate. So y differentiation is going to be 1, plus e to the power x I have to keep as it is. Then the sin y differentiation is going to be what, cos y. Okay, so now CR equation, what it says, ux is equals to vy. So we have this term ux is equals to vy, and vx is equals to minus uy. So we have this term, so this is e to the power x sine y, so this is vx is equals to minus of this uy. So therefore the given function f of z satisfies the CR equation. Therefore f of z is equals to z plus e to the power z is analytic, is analytic. Then we have to find its derivative. The derivative is nothing but dw over dz. Okay, so this dw over dz, how we are going to write? This is nothing but f dash of z. So from equation 2, in while discussing CR equations, we have ux plus I Vx. It means we have got this as a second equation, means partial differentiation with respect to x, partial differentiation with respect to x, u and v term. Okay, so we already know this ux and vx, that we will directly substitute here. What is ux? Ux is nothing but 1 plus e to the power x cos y, so that I am going to write it here, 1 plus e to the power x cos y plus I Vx we have the term, that is e to the power x sine y. Now we'll what we are going to do, we are going to take this e to the power x term common. Okay, so and we'll simplify this one, that is dw over dz is equals to f dash of z is equals to, so how we are going to simplify this, 1 plus e raised to x, I'll take common, what remains, cos y plus I sine y. Okay, so this cos y plus I sine y, how can I rewrite? E to the power x, so this is going to be e to the power I y. Then 1 plus, again if by mathematical induction, if I use that a to the power m into a to the power m is equal to a to the power m plus n, so in the same way e to the power x plus iy, so that is nothing but 1 plus e to the power x plus iy is nothing but what, e to the power z, so this is dw over dz. Okay, so this is derivative. If we differentiate this function f of z is equal to z plus e to the power z directly, okay, dw over dz, z differentiation with respect to z is going to be 1 and e to the power z differentiation is e to the power z only, so this is satisfied.